resources. I ran into GIS while doing my PhD at the University of Texas, and it became my part of my dissertation work. I'll always tell people I do GIS because I'm lazy and I want to model the world, but I don't want to do it by hand. And GIS is a great technology to support our water resources modeling. And that became my career. So after 6 years in consulting and 8 in academia as a student research associate and professor, I joined Esri about 25 years ago and have been working on implementation of GIS with our water resources users since. So it's a bit about me. And what we are going to do now is really do a very quick overview of Arcadia. We'll discuss status of Arcadia transitioning Pro and general future activities. And we'll dive into a couple of specific areas that we'll be focusing this year, primarily the hydro feature extraction and support for hydrologic hydraulic modeling. And then we'll close a little bit with a discussion about our community engagement. But before we really dive into things, well, we got an Arcadia product icon and a glyph. It's a beautiful artistic rendition of key Arcadia concepts. We have representation of a water as this little water drop defined by the arrows. We have a landscape representation with this little mountain in the middle. We have flow represented by the arrows themselves, and we have the watershed represented with the arrows flowing to an outlet around our landscape. So our art department really went all out in putting this together, and so big shout out to them. So now that we have these, the icon and the glyph, you'll be seeing it all over the materials that are related to the any of the Arcadia activities. All right, so we'll start with what is Arcadia, and this is kind of really important because many of you are new to Arcadia, and you might wonder what that is. And Arcadia, to start, what it's not the hydro tools in the spatial analyst. So Arcadia is a little bit more than that. So the idea behind Arcadia is to provide GIS framework for development of integrated analytical systems for water resources. So there are several key elements in this foundational idea. It's a framework, not a solution for a specific water resources problem. So it's not an H&H model. It is geared toward analysis and not cartography. So that's really, really important because our foundation is built to support analytical use of the tools. And it's definitely not a black box, but a set of tools and methods that can be used within the context of other capabilities that ArcGIS provides. So it's value added to your core GIS skills. It includes the data model, that's how it started, a bunch of tools that we'll talk about today, workflows on how to best use the tools for particular use cases. It's not all about single use, but very often about the sequence of the tools. And the community of users with common interests and patterns of use. That's you. In Arcadia, we have many tools and workflows in many different areas of water resources. We have over 250 tools in Pro, and that number is constantly growing. We have more tools in ArcMap. I'll talk about it in a moment. But all the new development is happening in Pro, and we just maintain the tools in the Arcadia tools in ArcMap. You'll most likely never use all of those tools, probably 40 or 50 tools that are specific to your needs and your domain of GIS implementation. And the trick is really to learn which are the tools that you really need and in what order you need to use them to build your analytical foundation. We covered a lot of detail about Arcadia in the last year's Arcadia webinar series. So this was a 4-part series, 1 hour each. And if you're new to Arcadia or interested in a specific topic along these 4 webinar focal areas, please review those recordings. They will straight you on the right path. All the recordings are available on demand and are free, so you can watch them during your awake hours. You don't have to get up at 3 in the morning to attend the live webinar. So since many of you are new to Arcadia, please review these. Start with the first one, the Arcadia in ArcGIS Pro, that will really lay out the foundation for what Arcadia is, not just in Pro, but in general. And you will see more detail about how Arcadia is maintained and some of the resources. And then the other 3 webinars really focus in specific areas and these workflows that we talked about. Some really cool new stuff in there. So here's where we are with the status of Arcadia development. About 3 years ago, we started focused transition from ArcMap-based Arcadia tools to Pro. Move to what we call baseline critical functionality was accomplished last fall with Arcadia for Pro 2.8 release. That is 235 tools that we think provide a solid Arcadia foundation to support most implementation in water resources. And now we are in the ongoing transition of remaining Arcadia ArcMap tools and maintenance of existing Pro base. So we are taking more advanced tools that have not been ported yet and put them into Pro, and in the process streamline, scrub them, and put them in the context of a larger workflows for a specific area. So this is indicates really activity focus areas that we were focused on up to now, and since the basic equivalency has been established, we are moving into more advanced and fun areas of implementation and some new areas that we'll be talking about today. So the key focal area for 2022 are where we are going to be moving some of the Arcadia capabilities to the web. So Arcadia is mostly desktop-based, but we want to go and expose some of the capabilities through the web, especially in the domain of flood forecasting and impact assessment. We want to be adding functionality for automated hydrographic feature extraction and some new capabilities in the hydrologic modeling support domain. Of course, maintenance as Pro goes through semi-annual upgrades, and that also includes maintaining the ArcMap version of Arcadia through any additional ArcMap upgrades. We don't expect many of those, but they do still happen occasionally. So we try to make sure that Arcadia will not break. And we are going to put a lot of emphasis on documentation and training. And so last year we did a lot of outreach, and this year what we want to do is make sure you not only know about the tools, but you actually learn, and we help you in the learning process of how to use these tools in your daily practice. So I'll talk about that some more. So let's dive into some of the new areas we are exploring and workflows and tools to come this year. We'll start with hydro feature extraction for flood modeling. And that's something we've been working on for a number of years and through several projects. And we are now transitioning some of those R&D efforts into also into the automated hydro feature extraction we'll talk about later. So the goal of these flood modeling support tools and workflows is to develop a horizontally and vertically integrated data set that can be used for floodplain modeling and integration with the national water model flow forecasts. And for many of our international users, this is the same infrastructure that can be used globally using either your local elevation data and forecast models if you have them, or if not, you can use in particular the global ECMWF GeoGlows forecast flow forecast services for the world at about 1 million reaches across the world. And you can use some of the freely and globally available elevation datasets as support. Now, they're not of great quality elevation datasets, but there are some that are pretty decent and will give you a good starting point. In US, we are focusing on using the NHD Plus high resolution data and national water model forecasts, and they're available across the whole country, so you can apply it systematically wherever you are. If you have hyper-resolution modeling, so detailed information, both topographic and modeling, you can plug that into the workflows. So the idea here is that the tools enable you to develop a series of flood extents for specific depths of flooding. And if desired, you can relay them to assets. So we are showing a bunch of addresses to measure the impact of those floods that are happening. So this is not true flooding at this point. This is pre-processing. So we generate these sequence of slices. We call them flood stack. And as we go, we characterize each of those segments and flood extents, and we can create synthetic rating curve that basically relates the depth of flooding or depth to the discharge. And so for each of these flood slices, so we have our rating curve, and then from the flow forecast models, we get the discharge forecast. So we get a forecast of Q, and then through this rating curve, we can relate it to H, and from the H, we can go and figure out what the extent is and what the impacts might be. And we can also develop this impact rating curve, which basically tells you for each of these stages how many impacts, in this case, number of address points are being affected at that stage. And so that can give you a very quick overview how bad your flow is. So going from the flow to the extent to the impact. The basic tools to do this were part of Arcadia for years, and they have been moved from ArcMap to Pro. So what we are working on right now is really taking the current efforts and putting them and optimizing them in Pro. So, which means both streamlining the experience, the user experience, and also making the tweaks to leverage the Pro capabilities that might not have been available in ArcMap. And our focus right now is on NHD Plus high resolution dataset and national water model forecast first. And we'll release that, and we are hoping to do that actually next week. So this is something that we are trying to just push out of the door. So now we are going to go into kind of R&D efforts, something that will take a little bit longer to develop. So it's really an R&D effort. And it's about automation of hydrofeature extraction. This is a hot topic as both USGS is working on the next generation of hydrography definition through their 3DHP program, as well as Fish and Wildlife Service on update to the National Wetlands Inventory. For my international users, think about, I like to call them blue lines on the maps. And so that includes where are the streams, where are the water bodies, and the water bodies can include both lakes and wetlands. And so that's your foundational hydrographic infrastructure. And the idea is, can we use the detailed information about the terrain to extract it automatically instead of having to do it by hand? So both these current efforts with USGS and Fish and Wildlife Service are really looking into automation of as many aspects of feature extraction and characterization as possible. So it's not only the location, it's also the properties of these features. Is something intermittent or perennial? What type of wetland it is, etc. We are working with both agencies and some of our partners to bring any interesting techniques that come out of this R&D to you through Arcadia tools. Now, this is definitely an R&D effort, so mature tools and techniques will take time to develop, but we are really excited to get this started. We think that the hybrid approach, where we combine artificial intelligence with more traditional GIS feature extraction techniques, might provide better possibility to achieve this automated hydrographic feature extraction. And so I'm going to talk a little bit about that. So what is AI and how does it relate to hydrographic feature extraction? Well, the simple definition presented here is, it says that AI deals with the simulation of intelligent behavior in computers. So in our case, the intelligent behavior is ability of a computer system to extract hydrographic features at the level that are acceptable by a hydrographer. AI is not just machine learning and pattern recognition. That is very powerful, practical, and in vogue right now. But AI has many other aspects. There is also logic rule or knowledge-based AI, and I'll talk about that today as well. So you'll see how that can be leveraged in what we are trying to do. So, why might AI be good for hydrographic feature extraction? Well, it operates within an automated framework, so we can repeat the process across different areas of interest or modify the process and reapply it to a specific area, either because we have better data or better models. And finally, allow us to combine factual and knowledge-based techniques in an integrated system. Another benefit of AI and specifically machine learning techniques is that they can process large volume of different indicators and distill them to just most significant components. So you are not overwhelmed by your data. And finally, results and predictions of AI techniques can be used to narrow down the manual processing only to critical areas where human intervention and interpretation is really needed. And this is really important to emphasize. We are not looking for perfection. We can expect that human interpretation might still be needed, but can we minimize it by having a good starting point using these automated feature extraction? So we're just going to cover some of the basic concepts here. There are many different types of machine learning frameworks, but fundamentally, they're all trying to do the same thing in different ways. And that is to really identify a certain type of features or their behavior. In our case, we are interested to separate the non-hydro feature characteristics from the hydro feature characteristics. So basically define that the line between the two types of features in the landscape. And there are different techniques to do that. In general, what you do is, you can use random forest techniques, and we'll talk about that in our wetlands identification capabilities, and then deep learning techniques that we'll talk about when we talk about stream extraction. So in this little diagram, we are going to use a wetland identification as an example, but really this figure applies to stream identification as well. So wetland identification starts with using the digital elevation model as its main input data set. We use it, possibly we smooth it first, and then use that terrain to derive some of the hydrologic and hydrographic topographic indicators of wetlands. That's coming out from the notion that we can use geomorphology as a proxy for where water is near the surface. So we are looking at things like distance to open water, slope, and curvatures. So these morphologic indicators are then combined with known wetland locations. So this then gets put in the training phase of the model development, in this case, a random forest model. And as a result, we get a trained model that we can use to make wetland predictions in other areas of interest. Additional inputs can be added as well. So you can add imagery or LiDAR reflectivity or other sources. And the beauty of many AI techniques is that it's easy to add additional variables and rerun the model. But of course, there is no guarantee that your model will be improved. So think about these AI techniques as statistical techniques. And sometimes adding variables helps, and sometimes it actually is a detriment. So the WIM, or Wetland Identification model, has been part of ArcHydro for a couple of years. It is a random forest machine learning method to identify wetland geography from topographically derived morphologic indicators. Since its release, we've added a new tool to streamline ground truth data segment. So it's this pre-processing ground truth data. And we are currently working with Fish and Wildlife Service to evaluate WIM in the context of their National Wetlands Inventory methodology. So we are applying WIM to different complex landscapes, evaluating additional wetland indicators that might help to improve the wetlands identification. And based on these experiences, we'll be adding tools and some workflows for derivation of new wetland indicators and providing recommendations for WIM use in specific areas. So right now you kind of have to figure it out on your own, the tools and documentation's there, but what might be good selection criteria in Piedmont areas versus flat areas, it just depends. So we will want to provide some additional feedback. We expect this to be done sometime in summer, around June or so, and we might do another webinar focusing specifically on WIM and these new findings in fall-winter time. The other area that we are working on, which is really in the early R&D stages, is using deep learning for stream extraction. You can also use WIM for stream extraction, but it has different approach to how things are evaluated. And so we think that deep learning might be a good or a better alternative, so we'll see. It's really using Esri's out-of-the-box deep learning model framework and a very specific deep learning model called the multitask road extractor, or MTRE for short. MTRE, in the context of road extraction, looks at two specific subtasks. One is to identify the pixels in the image that belong to a road, but at the same time, also look at the connectivity and tracing of the lines that make the roads, because we know that roads form a connected network. So we apply this model to stream extraction because there are obvious similarities in the two tasks between streams and road extraction. But instead of using image as an input as we do for road extraction, we use morphologic indicators as inputs for stream extraction. So no, I will not go into gory details of how this is done, but we'll jump to the results, and we can look at we'll take a closer look at some of those results. So the zoomed in scenes, in the blue boxes here, so these two show the predicted streams as red and the verified streams in blue for comparison. And by the way, these testing streams, the blue lines, have not been used to train the model. So this is really just the validation part of it. So training was done in different areas. So there are a couple of areas here where we have a really good match, both flowing through this wiggly area here, and also covering some of the areas along this larger water body. But some lower order streams are missing, so we are not capturing these guys, and we have some missing connections. So yeah, it looks good, but it's not great. And these errors could be due to the scale of topographic patterns that are being modeled, so the resolution of the DEMs and creation of the derivatives, all are also due to the relatively small training data set. So the more data you have to train it on, you expect that better results you'll get. So results here could be improved by optimizing the way the DMs prepared and transformed, or having additional areas that we introduce into calibration of the model. Well, but also the processing itself does not consist only of actual processing, that would be done through the AI component. But once that is done, we often apply reasoning, we look at the results, and then we make some decisions. And we as people, humans, decide why we like certain elements in the results and why we don't like others, and we just get rid of them. And this is where we want to bring in the rule or the knowledge-based aspects of AI into play. So if you were into AI in the 80s, there was a lot of effort that went into the area of expert systems. And during that time, machine learning was in its infancy. And so the pendulum has swung, right? And so now there is a lot of effort in the machine learning side of things and not so much in the expert systems. But I think we should do both. So what's interesting here is that the expert systems are supposed to offer intelligent advice or take an intelligent decision about the processing function. So can we capture these decisions that a human would make, translate them into the rules, and apply them on top of the factual processing results and come up with a better solution? So I'm not going to really walk you through the details here, but the most important piece here is that the rules in a true expert system are kept independent from the inference engine, so meaning the application of those rules. So you don't have to program the rule execution. So you focus on the rules, and the existing knowledge-based inference engine will apply the rules based on the content of the rules and the data that they're being applied to. So think about your conventional programming. Each time when you go and you're a developer, you do a work, you go to your analyst, they look at the results and say, oh man, if you can just add this to your code, wouldn't that be great? And then you have to reprogram the computational engine and built-in decisions if you're doing a bunch of if then else statements. With knowledge-based systems, you don't have to do that. All you have to do is go and say, well, what is the new rule that you want me to apply to? And then it just gets rolled into the implementation. So that really gives you the ability to do this incremental growth, and you can start with simple rules and then make them more complex as you go ahead. So what we really want is a bunch of rules, and that's a work in progress, something that we really want to focus on during this year. I'll skip this part, show you some of the interesting things that we are working on in the domain of hydraulic modeling support. We are adding capabilities to our hill slope and critical duration toolset. We've added a new tool and tweaking out the code and the workflow to minimize necessity for user intervention. And we should have the updated documentation, including the user guide and the sample data set within next month or so. And on the hydraulic side of things, we have added additional capabilities for support of HCC Res. We have a couple of two new tools for creating GeoRes layers and importing the layers into that structure. And we have also added the capabilities to calculate some of the most popular attributes for the cross sections. And within next month or so, we should also add capability to calculate roughness coefficients and left and right flow path lengths, and exporting them into SDF format. All right, so now let's talk a little bit about the community engagement. On a development perspective, Krista gave you the other aspects of the community engagement. So this year we'll do a lot of work on getting started. We'll do updates to documentation, training. So we'll reestablish the training program, hopefully live, both on Arcadia and H&H training classes. So they'll be revamped both in content and the tools. I want to show you a couple of documents so this is a world premiere of these documents to get you started. Two very short documents that